So number 7 says, base your base your answers to the following questions on the map below and on your knowledge of Earth science. The map shows the 4 time zones and some latitude and longitude lines across the continental United States. Some cities are labeled on the map. Which city has the shortest duration of insolation on December 21st? So remember, when you see the word duration of insolation, as we've learned earlier, that represents, right, number of daylight hours. Number of daylight hours. Okay. And so it says, which city has the shortest duration of insolation on December 21st? December 21st is the winter solstice. All right. And here's the thing about the winter solstice, and I'm going to scroll up to a previous problem. If you take a look at number 5, right, it shows you right here on day 3, we identified this as the winter solstice. And what do you notice about the cities that are more northern? The higher the latitude is, right? Look what happens to the amount of daylight hours. The daylight hours start to decrease as you go higher and higher in latitude. So all this is there to let us know. All this is here to let us know, back to number 7, is here to let us know which city has the shortest duration of insolation. It has to be the most northern city. And which city is the most northern, right? The one that's closest to the North Pole is going to be Seattle, which is choice A. So the more northern you are, and it's the winter solstice, the less amount of daylight hours that you're going to get. So number 8 says, the diagram below represents the plastic hemisphere upon which the lines have been drawn to show the apparent paths of the sun at a location in New York State on the first day of each season. Letters A through I represents points on the path. Which point represents the sunrise location on the first day of winter? All right. So one thing we have to keep in mind, right? The sun's path in this location, the sun's path that's at the highest point is definitely the summer solstice, right? The sun's path that's directly in the middle is going to be the equinox, and the sun's path that has the lowest right here, that is the winter solstice. So that lets me know I'm only going to be focusing on this sun's paths right here, okay? Because that deals with the first day of winter. So that's something to keep in mind. So now we know on the first day of winter, and you are in New York State, the sun rises, and this is something you just had to remember, the sun rises southeast and sets southwest during the winter solstice. All right. So when I take a look, I'm going to erase all this now. But when I take a look, one of the things I notice, if north is here and south is here, that means east is going to be right here, and west is going to be where H is. So if the sun rises southeast, that means the sun is going to rise between south and between east. What letter is between south and east? It is choice D. And so choice D is the correct answer. Number 9, it says, base your answers to the following question on the diagram below and on your knowledge of earth science. The diagram represents the apparent path of the sun as observed at 4 locations, A through D, on Earth's surface on the same date. The present positions of the sun represent the same time of day at each location. The zenith, the position directly overhead, is shown for an observer at each location. Diagrams are not drawn to scale. And it says, during the course of the day, which location has the greatest intensity of insolation at solar noon? All right. Which location has the greatest intensity of insolation where at solar noon? What do we know about solar noon? It's when the sun is at its highest point. When the sun is at its highest point. All right. And how do I know where's the greatest intensity of insolation? Is when the sun's altitude is the highest. Is the highest. So I'm going to look at location A, B, C, and D. And which one will the sun be at the highest point at solar noon? Okay. So when I'm taking a look, and I'm just going to mark, just for the sake of color, I'm going to mark, let's say red, okay? So at location D, right, it's all relatively in one altitude, right? So even if solar noon, the person would be, the sun would be right here, solar noon. At location B, the sun would be right here. I'm just marking an X where solar noon would be. At location A, the sun would be here. And at location C, the sun will be right here. Which 4 of these is the sun at the highest point? It's the one that is at location C. The sun is actually at the highest point at location C than any other location. So that's why the correct answer is going to be choice D, which is location C. All right, just because when the sun is at solar noon, it's at the highest point than any other location. Number 10 says, base your answers to the following questions on the graph below and on your knowledge of earth science. The climate graphs represent data from 3 different locations in North America. Line graphs show the average monthly air temperature in degrees Fahrenheit. Bar graph shows the average monthly precipitation in inches. A circle dot indicates each locations on the map. Let's zoom in. So it says, explain why the noontime altitude of the sun, angle of insolation, is greater at Monterrey, Mexico than at Calgary, Canada, every day of the year. Why is the noontime altitude of the sun greater at Mexico than at Canada? Well, let's see. Canada is located right here. And Mexico is located right here. Which location is closest to the equator, right? The closer you are to the equator, the higher your noontime altitude of the sun will be, the higher the angle of insolation. All right. And so that's why, because of the fact that Monterrey, Mexico is closer to the equator, that is why that is the correct answer. So I'll just show you. Oh, sorry. Here we go. Let me just scroll so I can circle the answer for number 10. Here we go. So you could have said any one of these, right? As long as it's mentioning that Mexico, Monterrey is located closer to the equator, or if you said Canada is farther away from the equator. All right, any of these options are fine. Base your answer to the following questions on the diagram below and on your knowledge of earth science. The diagram represents the apparent paths of the sun observed in solar time. Time based on the sun's position in the sky at Albany, New York on June 21st and December 21st. A portion of the sun's path on June 21st is shaded. A protractor has been included in the diagram. On the diagram above, draw an X. So that's what it tells me to do. Draw an X, not a whole path, just an X to indicate the position of sunrise on March 21st. Well, what do I know about March 21st? That is the equinox. What else do I know about March 21st? At March 21st, the sun rises east, only east, and sets west. All right? So because during the equinox, the sun rises directly east, I'm going to mark an X that is directly east. So if your X is labeled literally right on the east, you would get full credit. All right, number 12. Base your answer to the following question on the diagram below in your answer booklet and on your knowledge of earth science. The diagram represents the sun's daily apparent path for the first day of the 3 seasons at 43 degrees north latitude. All right. The solid lines represent daytime paths as seen by an observer at this latitude. The dashed lines represent the nighttime paths that cannot be seen by the observer. All right. On the diagram, draw an X. Once again, it tells me to draw an X to represent the solar noon position of the sun as seen by the observer on April 21st. All right. So here's what I do know. Let's say, remember that throughout the year, right, that the sun's solar noon position, it reaches a maximum height of where June 21st is, and it reaches a minimum height where December 21st is. So what does that mean? Throughout the year, the sun solar noon position is basically rising and then falling, rising and then falling, rising and then falling. It does that throughout the entire year. So now I gotta figure out, okay, where is April, right? You may be thinking, well, technically, well, can April be between March and December, or can April be between March and June? What's another way of finding out? Now, one thing you have to remember is they equal the same amount of months. So from March to June 21st, they are 3 months apart, right? So you may be saying, well, shouldn't these two dates be 3 months apart too? You're absolutely right. But remember, for an equinox date, not only is it March 21st at this location, it's also September 21st at this location too. They're right. Same position, 2 different dates. So now if you notice, if we follow the pattern, right? September's here, September, October, November, December. Then January, February, March, and April. All right. So April is located right here. So where would you draw your X? You would draw your X anywhere between March and April on this line because it has to represent the position of solar noon. If you didn't draw the line, if you didn't draw the X on that line, then that means you made it incorrect. All right, number 13. It says draw one arrow in each box on pad Z to represent the sun's apparent path or movement direction along pad Z. We know what the background question says. It says, base your answers to the following questions on the diagram below and on your knowledge of earth science. The diagram represents the sun's apparent paths on the equinox. On the equinox. And the longest and shortest day of the year for a location in New York State. Point X, Y, and Z represent the solar noon positions along Cayley-Dunn's paths X, Y, and Z. Why is this important when I'm talking about the path of the sun? During the equinox, we just said the sun rises east. Right? Sorry. Right. The sun rises east. The sun rises east and the sun sets west. All right. So when I'm looking at this path, I know that my sun has to rise. So even let's say we didn't even know about this, right? About the equinox. Let's say it didn't even matter where you knew exactly where it was going to be. Let's say you didn't even know that. Here's what I do know. The sun rises right here on the east side, no matter what date it is. So whether it's June 21st here, whether it's the equinox date here, or whether it's December 21st, right? Whether it's March 21st, all right? You know that the sun has to rise on the eastern side. And we also know that the sun has to set on the western side. The sun setting takes place here, and the sun rising takes place where the purple pink is. So that being said, when I'm going to draw my arrows, right, I'm going to draw where the sun is rising up on the eastern side and it's setting towards the western side. And so that is your correct answer, how your arrows should have been drawn. All right, we're going to do 14 and 15 together. Base your answers to question 14 and 15 on the diagram below and on your knowledge of earth science. The diagram represents the apparent path of the sun for a location in New York State on October 21st. Three positions of the suns are labeled A, B, and C. The length and direction of the shadow of a vertical stick are represented at 3 different times during the day. Compass directions along the horizon are labeled. Question 14. It says identify the letter. So your answer has to first identify one of these letters. Identify the letter of the sun's position where it is closest to solar noon. State one piece of evidence. Not two, not three, not four, not five. One piece of evidence shown in the diagram that supports your answer. All right. So how do I know which letter of the sun's position where it's closest to solar noon? Where is the sun at the highest position out of these three, right? The sun is at the highest position right here. So you could have mentioned anything that talks about the fact that the sun is at the highest position. As a matter of fact, I'm going to transition to show you the possible answers, what you could have said. And the answer is letter B, by the way. All right. So if we take a look, 14, right? The answer is letter B. And you could have said any of these two answers, that the sun is closest to its highest position, or the sun is nearly overdue south, near halfway into its path. You could have also mentioned the fact that if the sun seems to be in the middle, like halfway between sunrise and sunset, that would also be fine as well too. But the main thing is that the sun is closest to its highest position, right? That's the best answer. So letter B with that, these explanations are fine. For number 15, however, for number 15, it says on the three diagrams, on the diagram above, write the letter in each box labeled sun position that caused each of the three shadows. So remember, the higher the sun's position, higher the sun, the smaller the shadow. All right? The higher the sun, the smaller the shadow. So automatically, this has the shortest shadow right here. So I know it's going to be position B, because position B is the highest altitude. The higher the sun, the smaller the shadow, right? Then where's the shadow that has the longest position, right? Where's the shadow where it's the longest? Right here. All right. If I want a long shadow, my sun has to be very low. Which letter is the sun very low? Right here, C. All right. And so right here, since the shadow is halfway between small and high, small and long, so therefore I need to pick a sun's position that is also not that high, not that low, which would be A. So CBA would be your correct answer. Base your answers to questions 16 and 17 on the diagram below and on your knowledge of Earth science. The diagram represents three apparent paths of the sun, labeled A, B, and C on the first day of each season, as seen by an observer at Binghamton, New York. The sun's position on path B indicates a specific time of the day. The compass directions are indicated on the horizon. So 16 says, state the relative intensity of insolation and the relative duration of insolation of the sun for path C compared to the intensity and duration of the sun for path B. So all your answers has to focus on path C. All your answers have to focus on path C. All right. So if I first focus, remember my answer has to be only about path C in comparison to path B. The fact that it says relative, that means I don't need a number, right? No number. I don't need a numerical value. All right. The intensity of insolation depends on the height of the sun, the altitude of the sun. So which has a lower altitude, path C or path B? Which one has a lower altitude of the sun? You are correct. Path C. So therefore, the intensity of insolation for path C is lower. All right. Next, I'm going to focus on the second part of the question, the duration of insolation. So between path C and path B, which one has a shorter path? Which one has a shorter path? Right? You've guessed it correct. Path C has a shorter path than path B. So that means the duration of insolation for path C is smaller, or you can say lower. It's up to you. The duration is lower, smaller. All right. Remember, all your answers has to focus on path C, not path B. And if you take a look, you look at the answers right here for 16, right? You could have said less intensity and shorter duration. All right. And this is for path C. All right. So number 17 says, on the diagram below, draw the path of the sun for November 5th. The line represents the sun path must begin and end on the horizon. Okay. So where is November 5th? So that means we're going to do some searching. We're going to do some searching. Let's do some searching. Okay. Well, what do I know? I know the date of the path sun that has the highest height has to be June 21st. All right. I know the path that has the lowest height or altitude has to be December 21st. All right. And I know the path in the middle has to be either March 21st, right? And September 21st. All right. Well, what do I know? If here is September 21st, and this path right here is December 21st, where is November? Well, I know if I look at September and I look at December, November is in between September and December. So if November is in between September and December, that means my path also has to be in between September 21st and December 21st. So your line should look something like this. Represent the path for November. Basic answers to questions 18 and 19 on the diagram below, which shows Earth on June 21st when the Northern Hemisphere experiences the most hours of daylight in a 24-hour period. The shaded area represents nighttime. It says state one cause for the different lengths of daylight shown on June 21st at these different northern latitudes. There's one reason why we have different lengths of daylight, and that is because the Earth is, oops, sorry. That is because the Earth is tilted, right? If the Earth wasn't tilted, then we wouldn't have different lengths of daylights. If the Earth was not tilted, right? If the Earth was not tilted, then we would receive similar amounts of daylight hours. But because the Earth is tilted, that's why we have different lengths of daylight. It's because the Earth's axis, there we go, the Earth's axis is tilted. And you can go ahead and just check, if you check your answers here, any of these responses for number 18 is perfectly fine. All right, any of these responses is fine. All right, if you said the Earth's axis is tilted, the Earth rotates on its axis. All right, anything that is focusing on the Earth's axis would give you leading you towards the correct answer. and the fact that it's tilted. Number 19, on the diagram above, place an X on Earth's surface at the latitude where the vertical ray of the sun would be directly overhead on June 21st. All right. There's only one latitude where the sun's rays will be directly overhead on June 21st. All right. First things first. All right. First things first. June 21st is the summer solstice. Is the summer solstice. And according to our notes, there is one latitude where the sun is directly overhead on June 21st. And what latitude is that? It's known as 23.5 degrees north, otherwise known as the Tropic of Cancer. Tropic of Cancer. So therefore, I'm looking on the map, I'm looking for either 23.5 degrees north, or I'm looking for the Tropic of Cancer. And what does it tell me to do? Place an X. Place an X. And so if you said, and if you wrote a line anywhere on the Tropic of Cancer, that's fine. If you did it here, if you did it right here, that's fine. If you draw an X right here, that's fine. Right here is fine. Right here is fine. They only said one X, all right? Anywhere on the Tropic of Cancer would be fine. Anywhere, not the equator, the Tropic of Cancer. Why? Because this is only focusing on what day? The summer solstice. All right. That's the end of this. Have a wonderful, blessed day. And I'll see you guys again. Take care, everybody.